relative velocity. All velocities are relative velocities. So in other words, all velocities are relative to some systems of reference. So we are most familiar with velocities relative to the earth. So when we say that a train has a velocity 100 kilometers per hour in a given direction, so we usually mean 100 kilometers per hour relative to the earth. So given that the velocity of a particle P relative to an assigned point is v1, and the velocity of Q relative to O is v2, then the velocity of P relative to Q is the difference of v1 and v2, that is v1 minus v2. v1 minus what? v2. Now, if the particles P and Q are moving along parallel lines, speed 40 kilometers per hour and 35 kilometers per hour in the same direction, then the velocity of P relative to Q is equal to 40 minus 35 kilometers per hour, which is equal to 5 kilometers per hour. That is, if the two particles P and Q, if they are moving along the parallel lines, is that okay? In the same direction. But if they are moving along the parallel lines direction, so we're going to add their space. Is that okay? So as they are moving in the same direction, we need to subtract their space. Is that okay? But if they are moving in opposite direction, for example, if a particle P and Q, particles P and Q are moving along parallel lines with speed 40 kilometers per hour and 45 kilometers per hour in opposite direction, then velocity of P relative to Q is equal to 40 plus 45. Is that okay? Which is equal to 85 kilometers per hour. Exactly. So if they are moving along parallel line, but if they are not moving along the parallel line, is that okay? They are not moving along the parallel lines. So what will happen? If the velocities P and Q are not parallel, to find the velocity of one relative to the other. Exactly. So if velocity v1 and v2 of P and Q respectively are indicated by this, so this is v1, then this is v2. Is that okay? Now let's look at this diagram now. So assuming that this is origin O, this is v1, this is v2. Is that clear? Now from O, this is draw OA. This is OA to represent v1. Here, this is the v1, and then OB to represent v2. This is v2 as indicated here. Now, since OB plus BA is equal to OA, that is triangle law of vector addition. Is that okay? Triangle law of vector addition, OB plus BA is equal to OA. If you now make this BA the subject of formula, we say that OB plus BA is equal to OA. So if you make BA the subject of the formula, so you need to transfer this OB to left hand side. So as you are transferring, the sign will change to negative, so that we have OA minus OB. So what is your OA? OA is V1. This is V1. Then minus OB. What is OB? Is V2. Is that clear? This one will now represent velocity of the relative velocity of P relative to Q. Is that okay? That is, the velocities of P and Q are not, so they are not parallel this time around. Is that okay? So P relative to Q will now be V1 minus V2. So if it is Q relative to Q relative to P. So what you need to do is just to change here, it will be AB. Is that clear? So what we are saying in essence is that so BA represents in magnitude and direction the velocity of P relative to Q. Similarly, the velocity of Q relative to P is represented by AB, which will be phi2 minus phi1. So what we have achieved here is that the relative velocity of any two particles moving with given velocities can therefore be found by drawing a simple vector triangle such as this triangle OAB. Then the closing side here, this side AB, either AB or BA, will represent the required relative velocity. Is that clear? So it will represent the relative required relative velocities. Is that okay? Now let's look at example 1 now. A ship is sailing due east at 15 kilometers per hour and another ship is sailing due south at 20 kilometers per hour. Find the velocity of the second ship relative to the first ship. So what you need to do here is, let's firstly draw the vector diagram. Is that okay? So this is the vector diagram. They said that a ship sailing due east. So let's say this is the origin. Due east is to the right like this. So this is 15 kilometers per hour. Then there is another one due south. This is from the origin here down will be due south, 20 kilometers per hour. So we are asked to find the velocity of the second ship. So this is the second ship relative to the what? First. So this is what we are asked to find. Is that correct? Okay. So this is what we are asked to find. So using Pythagoras theorem, because this one is a right angle triangle, so to find, so let OA represent the velocity of the first ship and OB represents the velocity of the second ship. Then AB represent the velocity of the second relative to the first. This is the second, right? Relative to the first will be AB. Is that clear? Now just use Pythagoras theorem as I said. So since AB is equal to AO plus OB, which is equal to OB minus AO, because this one now, if you want to interchange the letter here now, so if you write O first now, that means we need to reverse this one. Is that okay? It will change to negative. They are the same. So also to use Pythagoras theorem for this first equation, AB square is equal to AO square plus OB square. Is that clear? So AO 15 square plus 20 square. So that one will give you this one will be 225, this one will be 400. 400 plus 225, that is 625. Then find the square root of both sides now. So square root of 625 is equal to 25. Is that okay? So it's equal to 25. Therefore, this line AB now, this line AB is equal to 25 kilometers per hour. Then the tangent of this angle, represented by theta, is equal to, tangent is adjacent over what? Okay, TOA, opposite over adjacent. So tan is opposite over adjacent. Then opposite to this angle is 20. That is why you're having 20 here. Then adjacent, because the longest side is always hypotenuse side. So here will be hypotenuse side. Is that clear? So you will not use this 25, just use 20 divided by 15. 15 will be adjacent. So 20 divided by 5 will give you 4. Then 20 divided by 15 divided by 5 will give you 3. So tan tangent of this angle now is equal to 4 over 3. Is equal to what? 4 over. So we're going to, that is that about example 1.